So I'm going to talk about operability and productization of big data, also TCO and TTV, and it's a privilege to talk after Eric. He's such a big icon in the Hadoop ecosystem. So before I go into the details of operability and productization, I'll set some context similar to Eric's talk as to what binds these deliverables in terms of having low TCO and quick TTV, time to value for big data projects. So if you look at big data journey so far, we had 3 stages. I'm ignoring the mainframes. The first stage was data at rest, a lot of databases in 1990s, 80s, last decade, and that did very well. And around 12 years ago, you saw the arrival of batch with MapReduce and Spark. And it was not a scale-up, but it became a scale-out, cheap model, and that started to take off. And over the last few years, you are now seeing data in motion, streaming, real-time compute, notably Apex, arrive. So in this context, I'll evaluate operability and time to value. Now, before I go, I do have to walk you through the do loop that Eric talked about. As we have gone from the waves of at rest, at batch to streaming, we have arrived at sub-second. In this ecosystem, you can actually now do analysis and act on data before you load. So you extract, transform, and before you load, you're able to act on it, which means that you actually have big data now that can do machine-consumable data because you can take the humans out of the loop. And in that loop, the big data application can send the data back to other servers and not require humans. And that's hugely disruptive. And that does put a much higher bar on operability and productization, as I talked about. So that's what it is. A do loop is where you can have a big data extract, transform, and act, and not have humans in the loop. Cool. So let's talk about productization and operations of big data, right? Nick Hudecker from Gartner, about a month and a half ago in Sydney, talked about current state of big data. 70%, he said, of MapReduce and Spark jobs fail to go to production. And that's a pretty big number. Even if it's 60, 50, it's a pretty big number, right? So why? Why is that so? So the way it happened was big data, since it was open source, became a developer ecosystem where developers did a lot of coding, threw code over the wall, and got going and kept on adding more and more features. And then what happened was a lot of companies, distros inclusive, had professional services as a business model. What that meant was that they made money by consulting and developing applications for you, and that effectively disincentivized them to productize and operationalize the technologies. Because if you do that, your PS money goes lower. And you have to wonder if that ecosystem would ever develop a very good in terms of productization and so forth, right? So let's look at Hadoop. It has really taken off. It's all over the place. Almost every nook and corner, you have a Hadoop vendor that does some kind of a professional services. In fact, it's all over the place. But I wonder sometimes whether open source has been a curse or a boon. Of course, it's a boon because you see a lot of companies take on Hadoop. It's a brand that is in every country, in every location, and so forth. But it's also a curse because if that is the situation after, let me guess, 12 years of MapReduce and 9 of Spark, it's a pretty bad situation. So just imagine this being a project that is internal to a company. What do you think a CEO or a CFO would do? They'll can it. You can't be running a technology for 12 years and have 70% of the jobs fail. So what happened? What happened was big data was neither productized nor operationalized, and happened because the DNA of the current ecosystem is extremely professional service oriented. This is the thought on which we started DataTorrent. We wanted to do something that actually addressed operation and productization of big data. Our business model is not professional services. We make money on selling products, and we iteratively and constantly keep measuring us in terms of how we do on lowering the TCO and lowering the TTV for our platforms. And Apex was a proprietary platform that was already in production in a lot of big brands for years before we open sourced. And that DNA of making sure that the technology actually serves the customers and it's productizable and operable has gone into Apex. As I had talked about earlier, it actually becomes much more harder if you want to operationalize and do such things when you want machine consumable data, because at streaming, the bar is much higher. But that's what we do at DataTorrent. We're not a professional service organization. We focus on productization and operationalization of big data. So before I go and discuss what they mean and how to measure them, let me just define them at a very engineering geeky level. So what's TCO? Cost of ownership. Cost to develop, cost to launch, and cost to continuously operate. The last part is much more important when it comes to TCO, which is a way to measure operability. For productization, you have time to value. You have time to develop, time to launch, and then time to continuously extract. Now, a lot of us think in terms of time to value as you launch, up and running, and go home. But in reality, even that has a lot of leftover after you launch, and you have to continuously extract value. And that's what it is. So in layman's term, how does it translate to what business look at for a project, right? So the questions they ask is, can an enterprise operate a product or an application to meet the SLA under the planned total cost of ownership? Simple. Secondly, can the enterprise extract full value in a timely fashion? That's the question the business guys ask. And today I'll walk you through different thought process on how to achieve that and what has gone into making Apex what it is today and what we do at DataTorrent. So first, I'll tackle operability. Operability can be defined in a lot of components. There are a lot of different ways of measuring operability. Well, for the sake of ease, I'll just list a few. First is SLA. You have latency, resources, or uptime. Second is fault tolerance and high availability. Okay, you need to do that because if things go down, you have to come back up on their own, and so on and so forth. So Hadoop had a lot of that, and Apex, we have gone a step further in terms of fault tolerance and high availability. Next is security ops. These are laws, and your apps have to be secure. We have again gone over and above what Hadoop has in Apex. And then there's resource cost in terms of scalability and performance. When you have millions of events per second coming, you need to be able to handle them and scale well, and the node resource cost has to be lower. Then there's DevOps, who are looking at ease to integrate and native operational support and be able to not have to learn a lot of new stuff. And then there's operational expertise, whether they can operate it on an ongoing basis. And then there's maintenance. Now, I can add some more, but these are among the top ones. Okay. Now, let's talk about laws of operability. Okay? Why do we need laws? Well, I'm a geek, I'm an engineer, and I like to measure stuff. Because without measuring and without elevator pitch, you really don't know how you're doing, right? So I'll try to establish some laws and some operability and some principles that we can use to see how we are doing in terms of TCO and TTV. So why are they needed? Because you want to measure, predict, forecast, and take actual decisions. And what I'm going to do is walk you through a fictitious situation where you have a choice between two options, and I'll evaluate a multi-cluster setup versus single cluster setup, right? So when we evaluate operability, I'll give a good example. Airplanes. They're supposed to, Boeing, jumbo jets, they're supposed to run 20, 30 years, 20 years, but they actually run 40, 50 years, and they just keep on running. That's operability. If I look at productization, you have iPhone. A 7-year-old kid can toggle it and get it to work. That's productization. So that's the kind of thought process we should have. So let's look at what happens when you have ETL pipelines with multi-cluster as opposed to a single cluster. Of course, biased towards Hadoop. So here's a fictitious pipeline that has 3 jobs. Job A, job B, and job C. Okay? Let's say we have to choose between 2 options. In one option, we have 3 clusters. Job A in the first cluster, job B in the second cluster, job C in the third cluster. In the second option, we are able to put them into a single cluster, and the code runs natively, in this case Hadoop, but it runs in a single cluster. And let's assume, for the sake of argument, that the uptime for all of them is 95%. Okay? Let's see what happens. For the uptime for the multiple cluster pipeline, The first cluster goes down 5% of the time, you lose some days. Of those days, you lose another 5%. And of those days, you lose another 5%. So by the time you're done, for no fault of the software, just on the hardware basis, just on the setup and the distributed operating systems and all of that, you'll end up losing 52 days. Now, if you're able to run that in a single cluster, it comes to 18 days. Now, when you do that, you actually have much higher uptime. Now, you also have to remember when you do that, you might lose some features, but you have to make this call because uptime actually goes up if you reduce the cluster. And this is a principle that Apex has followed with Malhar, as I'll establish later. Cool. So let me look at the components I talked about when you have n cluster situation. Uptime, as we just found, is an AND function. Uptime 1, and 2, and 3, and 4, n. So if you reduce n, you increase your uptime. Cost is a summation, because you have to have the expertise for first cluster, how to operate, how to train, how to learn, for second, and so on and so forth. Again, it goes worse. Single point of failure. If you have more clusters, one goes down, you're out. Again, it goes worse. Ease of integration. The DevOps have to integrate each of those components, each of the clusters in the monitoring system. Again, it goes worse. And security, same thing. Each of them have to be secure. So if you notice, it actually hurts. So I was saying, if you don't want to juggle too much, don't throw too many eggs in the air. If you have 10 eggs, it's much worse than 2 eggs, because one of them might fall. And it so happened to one of our customers, about a year ago, they launched, and they had Kafka, Camel, I'm missing something here, Uzi, MapReduce, DCP, and Scoop. And it was a delayed bad job, and they replaced it with Kafka and Apex. Similar code, similar functionality, but in real time, that's a win. But guess what happened to operability? It dramatically shot up, right? And that's the take. So Eric talked about Lambda architecture. How many of you are familiar with it? Well, guess what? You're just doing 2 pipelines, completely independent, for the same job. Guess what that does to operability? It toasts it, right? So we're seeing emergence of reduction of clusters, reduction of technology in our ecosystem. And as Guy tweeted out, we call it a cache architecture. Kafka, Apex, Spark for machine learning maybe, and then you have HDFS or S3. And we're seeing a lot of those. In fact, the customer I talked about was just Kafka and Apex. It actually reduces complexity, and it makes life much better. Cool. I also want to walk you through a launch that happened earlier in 2016. And I just want to walk us through this. It's a very heavy slide, but I want us to feel what happens when a big data project is launched to production. And once I do this, it will be pretty obvious why 70% of them fail, right? So functional design, I can't name what it was. The company doesn't want to be on the logo, but it's a big Fortune 10 company. So they had a simple job. They dumped from a database. They read the file. Then they had some joins. On that, they applied some rules. They got some results, and they were done. Not that complicated. The design was done on a piece of napkin in a week, coded in a month or 2, but then they had to launch. And they had to figure out parallel reads, parallel writes, skew analysis for the entire data flow, which designs met the SLA, make changes, analyze single point of failure, bottleneck analysis, and so on and so forth, and on and on and on. You get the picture, right? Now, by the time I'm done, you'll notice why 70% are not in production. They have failed because somewhere along this line, they got rejected. Just imagine my hand is paining, just clicking on this click. And this poor guys, for 6 months after the coding and design was done, had to go back and change stuff, and come back, and it was horrible. They went to production. That's not the point, but that is where we are failing, because we are underestimating the operational headaches to get a big data project out. And an ecosystem that does PS, professional services, all the time is not incentivized to solve this problem. You need new companies like DataTorrent and communities like Apex to actually think differently. Now, how does it translate to numbers? Me being engineer, I got to have numbers, right? So my take is that functional cost is less than 20%, and I'm being lenient. And operational cost is over 80%, and I'm being conservative. It's actually worse, and that's the cause of big data projects today. So I had promised some guidelines and laws, so now let's rehash them. Operability is inversely proportional to the number of clusters in a pipeline. It absolutely is. Don't throw an egg in the air if you can't catch it. Don't even bother. It's okay to give a feature than to compromise on operability. And you need to think hard about it. If you really want a cluster, there has to be a reason for it. For example, Kafka. You need a message bus? You need a Kafka. You need a message bus. Solus or whatever, right? Can't do it. But then you have all kinds of connecting technologies that you don't need. You should drop them. Cost is 20% functional and 80% operational. Operability is a first-class citizen in a platform. It can't be slapped on. A lot of big data technologies do that blunder. They're open source junkies, they do coding, and then they look around and give you something to do, and that messes it up. A platform like Apex has it inbuilt. It's a complete separation of functional and operational code, and you want operability to be taken care of by the platform and not by user code, and we have that in Apex. And last but not the least, the lesson that the company that I just talked about learned is you should be talking about operability and planning it out on design day one. They had a lot of fixing to do after they bumped into it. Thankfully, they launched. Okay. Cool. So I had a photo that I blogged about a year and a half ago, 2 years ago, is what I really believe in. Operability has been the graveyard of big data projects. That's the reason why today 70% of the projects, after 12 years of MapReduce and 9 years of Spark, still fail to go to production. And look around, missed SLA, failed launches, missed time to market, costly upgrades, all of it, okay? And the problem we still have is the ecosystem is full of dev engineers who'd like to throw a whole bunch of features off the wall, and it doesn't go to production. Okay, so now let's talk about productization. So this is where big data today is, okay? It's a slide that shows a lot of car parts, right? A lot of tires, technology is thrown out there. I can just take a crack at this. Kafka, Flume, Pig, Hive, Edge Catalog, Edgebase, MapReduce, Spark, Uzi, Tez, and I'm not even done yet, but more, right? What we say is, here's all the technologies, go do something with it. And you know what? I couldn't get a picture from Google where you had different tires. They all had the same shape. In reality, if you look at big data, some are round, some are wooden, some don't have air, some is oval. It's a pretty horrible mess. And the ecosystem that makes money on consultancy is reveling in it, okay? That's not what it's supposed to be. If you want to productize something, it must be a consumable product. It must be something that you can consume immediately. And you cannot be throwing a whole bunch of technologies at people and say, go build it, right? That's where we are hurting today. And that's today. And notice, I don't have the guts to put a real car in there. I put a toy car. Because we are so bad today in productization that for me to show real car and real product would be way in the future, which I'll do. But that's where we are today, okay? On this side, or on that side for you guys, you have technology. And that's a problem, because what you really need is this side, which is a product. And product is something that doesn't have 70% of these people not going to production. Product is something that will get you to maybe 90% success rate, not 30% success rate. That's what we need. But I'm here to talk about future. I'm here to talk about what Apex should strive for. I'm here to talk about what we at DataTorrent strive for. So let's look at what it should be and not do toy cars. Because when we aspire, we should be aspiring for something big. So what's a product? Again, me being a geeky engineer, I like components, right? Not long paragraphs. Number one, UI. That's Tesla. A good UI is important. In Apex, we provide a lot of app metrics, a lot of system metrics, full web services. DataTorrent has its own really high-level UI, but you can use your own UI. And it's extremely valuable because it takes away you from the technology side to the product side, right? Second part is integration. That's where Malhar comes in. Remember, the Camel and the DistCP and the Scoop went away because Apex did all of that. The code was there. It met 90% of the requirements, and you're done. And that's what integration is to be able to integrate on different technologies, because Hadoop is not a new technology. It replaces current ETL projects. So that's very, really important. And third but not the least, ease of use. And templates, solutions that we're doing now, and you have a lot of them in Apex, is what that helps you out with. But since we're aspiring, I like to really go what I talked to you guys before. What's the real product? iPhone. It does all of those things together. So I really think in Apex and in DataTorrent, that's what we should be looking for. And today, if you go back, that's where we are. Okay? We need to make the progress from here to finally here. Okay? Cool. I have a last slide. And this comes from my guts. This is how I feel. And I'll walk through it. For me, an operable software is something that successfully launches in short time to value and successfully operates with low TCO. Without that, it's just technology. Without that, we are where we are with big data. 70% of the projects failing. It's an insult. But I want to leave you guys with a thought, right? And that thought for me is very critical. For us in DataTorrent and Apex should be very critical. That's a very bad statement. Customers don't pay for our software. Are you kidding me? Customers pay, users don't, right? But that's not true. At a very gut level, in reality, what's really happening is they're not paying for software. They're doing something much more important. And I've seen it happen over and over and over in big data. What they do is they don't pay for your software. They do something much more important, is they bet their career on you, okay? I have never seen anybody got fired for using a wrong browser. I never heard, oh, you use Firefox, you should be using Chrome, you're fired. No, it doesn't happen. Browser is not a problem. But I've seen in big data, when 70% of the projects don't launch, someone is getting fired. Someone is getting reorged. I've seen customers who had 4 managements in the last 4 or 5 years, or last 6 years. Because they come, they fail, they move on. And as a community for Apex and DataTorrent, it's our job to make their career succeed. It's not our job to make money on PS. It's our job to make their career succeed. And that's the high level we should aim for. And that is what is required for us to eventually succeed in terms of TCO and TTV.